we come to the third part of the training video for knowledge test on basic electronics worksheet completion. On the second page of the worksheet, you are looking at question 4. It says to redraw the circuit diagram to replace the switch with an appropriate sensor so that the lamp, in this case we are referring to the LED here, so just make that little correction. Alright, light emitting diode instead will come on or will light up in the event of darkness. Now there are a few things that you need to consider here to replace the switch which was previously here. So instead of having the switch now, we are going to remove it and we're going to replace it with an appropriate light sensor. Why is it a light sensor? Because we're talking about when there's light or when there's no light. Okay, so we're talking about light conditions or dark conditions in this case. So light sensitive device such as the light dependent resistor will be useful. Referring to your textbook, you will first need to understand how a LDR actually works. So in this case, this is the circuit symbol for the light dependent resistor. What it represents here with the parallel rays here is that this resistor depends on light. The other thing that you need to know is that when light shines on the LDR, the photosensitive materials here will actually reduces the resistance of the resistor. In other words, when there's light, resistance decreases. So when there's light, resistance decreases. When there's no light, resistance increases. So it's an inversely proportional relationship between light intensity and the resistance. Okay, so just to reiterate, when there's no light shining on the LDR, the resistance is very high. So it behaves like an open switch. When there's light shining on it, especially very bright light under sunlight conditions, for example, its resistance drops drastically. It behaves like a closed switch, as if it's just a piece of wire, so current can pass through it. So having understood how the LDR works, we look at the conditions. Okay, this is the one that's appropriate to our question. So when there's no light, what happens here is that the current cannot pass through because the resistance is very high. Very little or no current passes through into the 1 kilo ohm fixed value resistor that protects the base of the transistor or the transistor itself, and therefore in this case, this is the lamp symbol. The lamp does not light up. When there is light shining for this circuitry, same circuitry, now is light conditions, it's the LDR resistance drops. So what happens is that now current can pass through freely and into the 1 kilo ohm resistor. Now this 1 kilo ohm resistor will restrict or limit the amount of current passing into it. Okay, so enough current is passed into the base of the transistor to turn on the lamp. Then the current actually passes through here, lighting up the lamp. So this is the condition as explained here. Now this is not what we want for these two. We want to be able to control, all right, using the LDR. So if you look at this configuration on page 289, when there is light shining, what happens is that current will flow through and some will pass through here, the rest will go through here. Between 1 kilo ohm and 10 kilo ohms, the current is not stupid, all right? It's smart enough to know that current basically flows the path of least resistance. So in other words, between these two, this resistor presents a harder path for the current to pass through, but some will still pass through. Most will pass through here, limited by the 1 kilo ohm, and therefore the transistor will be turned on. And hence the lamp will light up when there's light. If we switch the fixed value resistor with the LDR now, so what you see here is that when there's light, okay, the resistance drops drastically. Current will actually pass through here more than into the base of the transistor through the 1 kilo ohm resistor. So when there's light for this configuration, the lamp does not turn on because the transistor is not turned on. Too little current passes into the base of the transistor. Most of the current will just bypass this way. So in this condition, when there's no light, when there's no light, the resistance of the LDR is very high. It behaves like an open switch, open circuit here. So the current will basically pass through here. All right. So the current I'm talking about is the current from your 6-volt power supply. And therefore, when it's dark in this configuration, the transistor is turned on and the lamp is turned on in dark conditions. So for us to understand this, we can actually apply over to here. In short, if you look at it, this LDR cannot be at the top half of this circuit, but at the bottom half. So we are going to draw the LDR at the bottom first. This is your LDR, and the little dot represents that is connected to the bottom wire that goes back to the ground or the negative terminal of the power supply. So in this case, instead of drawing the 3-volt circuit symbol for power supply, I simply just put down here as 9 volts. It can be 3 volts, 6 volts, 9 volts, and ground here. So our focus is actually completing the circuit over this side. I forgot to highlight that this part here is basically the same from the previous question 2. I pause here for now. So to complete the circuitry for question 4, if you were to refer to our reference text, it is actually the symbol of a fixed value resistor. In this case, it should be 10k ohm, similar to the circuit above. So if we were to draw this, don't forget the little dot and make sure that the wires actually join. You can actually indicate here is the fixed value of 10 kilo ohms. So this is the complete circuit for answering this question. So let's run through very quickly again. When there is no light in darkness, right, the resistance in the light dependent resistor LDR is very high. So it behaves like an open switch. So no current can pass through, right? And of course, current now will pass through the 1 kilo ohm fixed value resistor. The amount of current is limited by this fixed value resistor, enough to turn on the transistor. And therefore, when the transistor is turned on, it allows current to pass through the collector, which is over here, out to the emitter, back to the power supply. So in this sense, the current will pass through the 680 ohm fixed value resistor and light up the LED. So this answers the question. If you were to refer to your revision guide, you will see on page 61, light sensing circuit. Again, this is for dark conditions, right? What is the difference here is, other than the voltage is not 6 volt, it's 9 volt, is this one here. This is a symbol for a variable resistor from 0 to 10 kilo ohms. So this arrow that crosses over the rectangle, which originally represents the fixed value resistor, now becomes a variable resistor. It will be a good idea to actually provide a variable resistor for your circuitry, like so, because down here you can actually answer the question here to allow for the sensitivity change in the above circuit. So I will explain that in a while. To continue answering this part here, what is the purpose of the 680 ohms resistor above the LED for this circuit? So obviously, you look at what is it protecting. It is protecting a sensitive output device such as the LED, because if too much current passes through a typical 2 volt rating LED, it will fuse. All right, basically what it means is the lamp will blow. So this LED will fuse, it will not work anymore, right? So this 680 ohm fixed value resistor limits the amount of current passing through the LED. So the LED will light up for a long time, okay? So same thing, all right, is to protect the sensitive LED, and basically that is the answer, all right? For this question, you can't actually set a 2-mark question or a 3-mark question, okay, because it's very direct. So I pause here for now. Alright, I actually filled up the answers for question 5. Just now earlier on I mentioned that this could not be more than a 1-mark question. I correct myself, it could be up to 2 marks. And the way you answer if it's a 2-mark question for this question will be, it is to protect the first mark, the sensitive LED, possibly this will be the 2nd mark, from fusing if too much current flows through it by limiting the amount of current flowing through the resistor. So you can actually have a 2-mark question for this question. Alright. So moving on to the last question, question 6. There are at least 2 possible ways of varying the sensitivity of this circuit here so that the LED will light up, alright, when not so much light is needed. When you first read this question, how can you change the sensitivity of the above circuit so that the circuit will not need so much light to switch on the transistor? Your interpretation could be when it is about evening time, alright, dusk, alright, D-U-S-K, when there's not much light, and possibly during sunset, and it's going to become dark. So that transition from bright to darkness will address this condition in order to switch on the transistor to turn on the LED here. So as I mentioned previously, to have the variable resistor here will be the convenient solution because you can actually vary the resistance from 0 to 10 kilo ohms and therefore limiting the amount of current that can pass through the variable resistor in the first place. So if you were to vary the resistance to almost 10 kilo ohms, very high, very little current will be able to pass through. Alright? So what it means in this case is that you will need a very dark condition in order for the little bit of current to pass into the 1 kilo ohm resistor in order to turn on the transistor and hence the LED. So if I actually wrote these answers prior so as to save time, varying the resistance value of the 10 kilo ohm variable resistor VR, lowering the resistance value say between 1 kilo ohm to 5 kilo ohms will allow the current to pass through the 1 kilo ohm resistor and turn on the transistor. So in other words, if I were to set and vary the resistance to the midpoint, for example, alright, 10 kilo ohms divided by 2 is 5 kilo ohms or less. So more current will be able to pass through, alright, and of course when this becomes darkness, not very dark, okay, maybe evening time there's still a bit of light, current will be able to pass through, some through here and some through there. And therefore your transistor will turn on and your LED will light up when there's not so much light needed. Now the second alternative proposal solution will be to replace the 1 kilo ohm resistor, this one here, with a 10 kilo ohm resistor will mean that in very dark conditions only then more current will flow into the 10 kilo ohm resistor to turn on the transistor. So imagine replacing this 1 kilo ohm fixed value resistor with a 10 kilo ohm, 10 times more, which means the current will be very little in order to pass through that 10 kilo ohms and attempt to actually turn on the transistor to turn on the LED. So only when it's very dark conditions, alright, almost all the current will be channeled through here into the 10 kilo ohm resistor to turn on the transistor in order to turn on the LED. So time for you to ponder, and of course don't forget to complete your mind map on the electronics and submit according to the timeline given. Alright, thank you and goodbye.